Hello science fans, are you ready for an adventure? Today, we are going to explore something truly exciting. We are going to talk about rockets. Not just any rockets, mind you, we are going to learn about water rockets. These are rockets that you can build yourself. Yes, you heard that right, your very own rocket. It is a fantastic way to see science in action, right in your back garden or a local park. Get ready to be amazed by the power of simple physics. Water rockets are incredibly fun for so many reasons. First, they are quite easy to make. You do not need lots of complicated parts. You probably have most of the things you need already at home. Second, they are a brilliant way to learn. You will see how forces and motion work together. It is like a science lesson that actually flies. Plus, launching something you built yourself is a super rewarding feeling. Think about the thrill of a countdown. 5, 4, 3, 2, 1, liftoff. Your water rocket will shoot upwards with amazing speed. It will climb high into the air, powered by water and air pressure. You can experiment with different designs. This project combines creativity with scientific principles. Prepare for some awesome water-powered fun and learning. Alright, future rocket engineers, let's gather our supplies. To build our amazing water rocket, we need a few key items. First, grab a clean, empty 2-liter plastic fizzy drink bottle. This bottle will become the main body of your rocket. It is strong enough to hold the pressure we need. Make sure it has its cap, though we might not use it directly for the launch mechanism itself. The bottle is our fuselage and our pressure chamber all in one. Next on our list is good old H2O water. Water is going to be our rocket fuel, or more accurately, our propellant. It is the mass that our rocket will push out to move upwards. You do not need any special type of water. Tap water works perfectly fine. The amount of water we use will be important, but we will get to that later. For now, just know that water is the stuff that gets ejected. Then, we need a cork. This cork needs to fit snugly into the neck of your 2-liter bottle. It is going to act as our plug and part of our release mechanism. Finally, we need a pump. A bicycle pump, or a sports ball pump with a needle adapter will do the trick. Make sure your pump is in good working order for this important job. Now for the super exciting part, building your water rocket. Take your 2-liter plastic bottle. This is your rocket's main structure. For a basic rocket, you might not add fins, but fins can help it fly straighter. If you want to add fins, you can cut them from stiff cardboard or a plastic sheet. Attach them symmetrically around the bottom part of the bottle, the end that will be pointing upwards when it's on the launcher. Use strong waterproof tape for this. The next step involves the cork and preparing it for the pump. You need to create a way for the pump's needle to go through the cork and into the bottle. Carefully, and with adult supervision if you are young, make a small, precise hole through the center of the cork. This hole should be just big enough for the pump needle to pass through snugly. Now let's think about the propellant. You will not fill the entire bottle with water. A common starting point is to fill about 1/3 of the bottle with water. Once you have water in the bottle, it is time to insert the cork. Push the cork firmly into the mouth of the bottle. Your basic rocket is now assembled. Let's talk about the science that makes your water rocket fly. It all comes down to a very clever scientist named Sir Isaac Newton. He came up with 3 laws of motion. These laws explain how things move or stay still. Your water rocket is a perfect example of these laws in action. Newton's first law is about inertia. It says an object at rest will stay at rest, and an object in motion will stay in motion, unless a force acts on it. Your water rocket sitting on its launch pad will stay put. It needs a force to get it moving. That is where the pressurized water comes in. Newton's second law connects force, mass, and acceleration. It is often written as F equals sine ma. This means the force, F, acting on an object is equal to its mass, m, times its acceleration, a. When your rocket expels water, that water has mass. The force of the escaping water causes the rocket to accelerate upwards. The most famous law for rockets is Newton's third law. For every action, there is an equal and opposite reaction. This is the key to your rocket's flight. Section 5. Under pressure, the force behind the flight. Pressure is a super important word when we talk about water rockets. But what is it exactly? Pressure is the amount of force applied over a certain area. When you pump air into your sealed water bottle, you are squeezing more and more air molecules into the same space. These air molecules bounce around, pushing against the walls of the bottle and the surface of the water. This pushing is what we call pressure. The more air you pump in, the higher the pressure becomes. This built-up pressure is a form of stored energy. It is like a coiled spring, ready to unleash its power. The air inside the bottle is compressed, desperate to expand. The only thing stopping it is the water and the cork. The force that launches your rocket comes directly from this pressure. When the pressure inside becomes great enough, it forces the water out of the bottle's opening at a very high speed. According to Newton's third law, as the water is violently pushed downwards, it exerts an equal and opposite force upwards on the rocket. This upward force is called thrust. Section 6. The countdown to launch, sending your rocket skyward. The moment of truth has arrived. It is time to launch your water rocket. First, find a safe, open area. A large field or park far away from people, buildings, and trees is ideal. Safety first, always. Now carefully pour water into your rocket bottle. Remember, about 1/3 full is a good starting point. Secure the cork firmly into the bottle opening, ensuring the pump needle hole is accessible and the needle can be inserted. With your rocket filled and sealed, place it on your launch pad. A simple launch pad can be made from a few bricks or a stand that holds the bottle upside down, nozzle pointing to the sky. Connect your pump to the needle that goes through the cork. Ensure everything is stable before you begin pumping. Double check that the launch area is clear. Now begin to pump air into the bottle. As you pump, you will feel the resistance increase. This is the pressure building up inside. Keep an eye on the bottle and the cork. Continue pumping until the pressure is high enough. Suddenly, with a whoosh and a spray of water, your rocket will launch. Watch it soar. Section 7. Slow-mo spectacle. Anatomy of a liftoff. Imagine we have a super high-speed camera filming your rocket's launch. Let's play it back in slow motion. As the internal pressure finally overcomes the cork seal, the first thing you would see is the cork dramatically popping out. Almost instantly, a powerful jet of water erupts from the bottle's narrow opening. This isn't just a trickle, it's a high-velocity stream, a torrent of H2O being forced out by the compressed air, desperately trying to expand. In these slow-motion moments, you would clearly see Newton's third law at play. The water shoots downwards with immense force. Simultaneously, the bottle, our rocket, begins its ascent. It starts relatively slowly for a fraction of a second, but its acceleration is rapid. The initial moments are a blur of water and motion, a testament to the power you have unleashed. Section 8. Upgrade unlocked. Graceful landings with a parachute. Your water rocket launch was spectacular. But what about the landing? Often it comes down quite fast. Want to give your rocket a gentler return to Earth? Let's add a parachute. For this upgrade, you will need a few extra bits. A lightweight plastic bag, like a thin bin liner or shopping bag, some string, and strong tape. A simple parachute can make recovery easier and reduce the chance of your rocket getting damaged upon impact. It also looks incredibly cool. First, let's make the parachute canopy. Cut a large circle or octagon shape from your plastic bag. A diameter of about 30 to 50 centimeters should work well for a 2-liter bottle rocket. Next, you will need to attach suspension lines. Cut several pieces of string, all the same length, perhaps around 30 centimeters long. You will need about 6 to 8 lines. Securely tape one end of each string at regular intervals around the edge of your plastic canopy. Now, how do we get this parachute to deploy? Section 9. Mission, debrief, launch tips, and staying safe. Congratulations, rocket scientist. You have built and launched your own water rocket. Here are a few top tips for future missions. Experiment with the amount of water. Try different levels to see what works best. Also, consider the launch angle. Launching straight up is usually best for height. Weather conditions are important. Avoid launching on very windy days. Safety is the most important thing. Always have adult supervision and launch in a large open space. Make sure everyone stands well back during the launch. Never stand directly over the rocket while pressurizing.